Our Earth, this precious blue marble, drifts through the vast, silent ocean of the galaxy, seemingly cocooned in a delicate, life-sustaining balance. It's easy to feel secure, grounded on familiar soil beneath a sky we've charted for millennia. But I invite you to look deeper, beyond the comforting veil of our atmosphere. Space, you see, is not the serene, peaceful expanse it might appear on a starry night. It is in truth a cosmic battlefield, an arena of unimaginable energies, filled with forces so powerful, so profoundly violent, they possess the capacity to extinguish not just us but all life, perhaps even the planet itself, in less time than it takes to draw a breath. Today we embark on a journey not to distant tranquil nebulae, but to the very precipice of cosmic danger. We're counting down 10 authentic threats, born from the very fabric of the universe, each capable of wiping out life on Earth in what would amount to, on a cosmic timescale, the mere blink of an eye. These aren't phantoms conjured from the pages of science fiction, nor are they distant abstract possibilities relegated to the far future. These dangers are real, they are quantifiable, and they are out there, lurking in the interstellar darkness, governed by the same physical laws that hold our world together. And the most unsettling thought of all, some of these cosmic menaces may already be on an inexorable collision course with our destiny. The universe operates on schedules far grander than our own, indifferent to our hopes and fears. It's a humbling, perhaps even frightening perspective, but one we must embrace if we are to truly understand our place in the cosmos. So steel your nerves, open your mind, and join me as we confront the universe's hidden perils. What we discover might just change the way you look at the stars forever. Imagine a colossal mountain, not of rock and earth bound to our planet, but a solitary wanderer of the void, a relic from the dawn of our solar system. This celestial behemoth, perhaps miles wide, is hurtling through the vacuum at speeds that defy earthly comprehension, say 40,000 miles per hour. It's an almost silent messenger from the deep, carrying with it a kinetic energy so immense, so concentrated, that upon impact, it would release more destructive force than every single nuclear weapon ever built by humankind, detonated simultaneously. This isn't hyperbole, it's the stark physics of cosmic collisions. We don't need to look far into the theoretical to understand the consequences. We need only ask the dinosaurs. 66 million years ago, an asteroid, estimated to be about 6 miles across, struck the Yucatan Peninsula, creating the Chicxulub crater. The immediate aftermath was a vision of hell, a blast wave that flattened forests for thousands of miles, unimaginable earthquakes, and a searing heat pulse that likely ignited global firestorms, baking the surface of the planet and turning the sky into a furnace. The very air would have burned. But the initial cataclysm was just the overture. The impactor vaporized, throwing trillions of tons of rock, dust, and sulfur into the atmosphere. This vast shroud of debris, along with soot from the global fires, blotted out the sun, plunging the Earth into a prolonged period of darkness and cold, a nuclear winter scenario, but triggered by a cosmic hammer blow. Photosynthesis would have ground to a halt on land and in the oceans, collapsing food chains from the bottom up. The oceans themselves would have become acidified from the sulfurous rain. The dinosaurs, magnificent rulers of this planet for over 150 million years, could not adapt to such a rapid and profound environmental shift. Our sun, that familiar life-giving star at the center of our solar system, is an object of immense beauty and power. We bask in its warmth. Its light drives our climate and sustains all life. It appears as a benevolent constant in our sky, but beneath this tranquil facade lies a colossal nuclear reactor, a seething cauldron of plasma, governed by unimaginably powerful magnetic fields, and sometimes this stellar engine erupts with a fury that can reach across 93 million miles to touch our world in profound and dangerous ways. These eruptions manifest as solar flares, intense bursts of radiation and coronal mass ejections, or CMEs, which are vast clouds of magnetized plasma and charged particles hurled into space at millions of miles per hour. Most of these are relatively minor, causing beautiful auroras when they interact with Earth's magnetic field. But occasionally, our sun unleashes something far more potent, a solar superflare. Such an event could have consequences for our technologically dependent civilization that are difficult to fully comprehend. We have a historical benchmark for such a solar tantrum, the Carrington event of 1859. On September 1st and 2nd of that year, a massive solar storm observed by British astronomer Richard Carrington struck Earth. Telegraph systems worldwide went haywire, sparks flew from equipment, operators received electric shocks, and some telegraph lines even continued to function after being disconnected from their power sources, powered by the auroral currents induced by the storm. Auroras were seen as far south as the Caribbean and Hawaii, so bright that people could read newspapers by their light at night. Now, transport yourself from 1859 to the present day. Imagine a storm of Carrington-level intensity, or even greater, striking our modern interconnected world. The first casualties would be our eyes in the sky, the thousands of satellites orbiting Earth. In the grand theater of cosmic events, there are explosions, and then there are. And among these, one phenomenon stands alone in its sheer, unadulterated power, the gamma-ray burst, or GRB. These are the most luminous and energetic explosions known in the universe since the Big Bang itself. Imagine the entire energy output of our sun over its 10 billion-year lifetime, released in a matter of seconds to minutes. That is the scale of a GRB, a focused beam of high-energy radiation, a true cosmic death ray. These cataclysmic events are thought to originate from some of the most violent processes the universe can muster, the collapse of truly massive stars, many dozens of times the mass of our sun, into black holes, an event known as a hypernova. Or they can arise from the collision and merger of two neutron stars, incredibly dense remnants of dead stars. In either scenario, as matter swirls into a newly formed black hole at relativistic speeds, powerful jets of plasma are launched outwards, punching through any surrounding stellar material and emitting intense beams of gamma rays. If such a beam, even from a relatively distant event, were to be aimed directly at Earth, the consequences would be nothing short of apocalyptic. Gamma rays are the most energetic form of light, and they would not be stopped by our atmosphere in the same way visible light or radio waves are. Instead, they would interact violently with the molecules in our upper atmosphere, particularly nitrogen and oxygen, triggering a cascade of devastating chemical reactions. Chapter 4. The Wandering Terror Rogue Planet Collision. Our solar system, with its planets orbiting the sun in a predictable clockwork dance, feels like a stable, ordered home. But the galaxy is not just populated by stars with their attendant planetary families. It is also thought to be teeming with cosmic orphans, planets unmoored from any star, drifting silently and darkly through the interstellar void. These are the rogue planets, and the thought of one wandering into our solar system is a prospect laden with catastrophic possibilities. How does a planet become a rogue? Some may have formed in isolation, coalescing from gas and dust clouds too small to ignite into stars. Others might be exiles ejected from their parent solar systems during the chaotic early stages of planetary formation, flung out by gravitational interactions with larger planets or passing stars. Whatever their origin, these worlds travel through the galaxy unbound, their paths dictated only by the subtle gravitational tides of the Milky Way. If such a wanderer, perhaps a gas giant many times the mass of Jupiter, or even a smaller Earth-sized world, were to stray into our solar system, its gravitational influence alone could wreak unimaginable havoc even without a direct collision. The delicate gravitational balance that keeps Earth in its life-sustaining orbit could be shattered. Our planet could be perturbed into a highly elliptical, unstable orbit, leading to extreme temperature swings, or worse, flung out of the solar system entirely, to drift alone in the cold, eternal darkness of interstellar space, a frozen, lifeless husk. Alternatively, the rogue planet's gravity could disrupt the orbits of other planets in our solar system, particularly those in the asteroid belt or the Kuiper belt. Chapter 5. The Invisible Maw Black Hole Drift-In. Among the universe's denizens, none command such awe and trepidation as black holes. These are not merely holes in space, but objects of such incredible density, such concentrated mass, that their gravitational pull is inescapable, even for light itself. They are the universe's ultimate prisons, warping the very fabric of space-time around them. And while they're often portrayed as cosmic vacuum cleaners, actively sucking in everything around them, their true danger to us might come not from direct consumption, but from a close, disruptive encounter. Black holes are typically formed from the death of massive stars. When a star many times the mass of our sun exhausts its nuclear fuel, it collapses under its own gravity, crushing down to an infinitely dense point called a singularity, surrounded by an event horizon, the point of no return. Stellar mass black holes, a few times the mass of our sun, are thought to be relatively common throughout the galaxy. And then, there are the supermassive black holes. Millions or even billions of times the sun's mass, lurking at the centers of most galaxies, including our own Milky Way. Chapter 6. The Pandora's Box from Beyond Alien Contamination. The quest to find life beyond Earth is one of humanity's most profound and compelling endeavors. We scan the skies with radio telescopes, send probes to distant worlds within our own solar system, and dream of the day we make that monumental discovery, evidence of extraterrestrial life. But within this noble pursuit lies a potential danger, a cosmic Pandora's box that, once opened, could unleash a threat unlike any our planet has ever faced: alien contamination. Imagine a future mission, perhaps to one of Jupiter's icy moons like Europa, or Saturn's enigmatic Titan, or even to the rusty plains of Mars worlds considered among the most promising candidates for harboring microbial life in our solar system. A sophisticated probe lands, drills beneath the ice or into the soil, and collects samples. These samples, containing precious extraterrestrial material, are carefully sealed and returned to Earth for study, carrying the hopes of scientists and the curiosity of all humankind. But what if, hidden within that ice or dormant in that alien soil, is something microscopic and alive? Not an intelligent being, but a simple microorganism, a bacterium, a virus, or something entirely different, based on a biochemistry unknown to terrestrial science. When we gaze up at the night sky, the space between the stars appears as a perfect, inky black vacuum. But this perception is an illusion. Interstellar space is not entirely empty. It is permeated by a tenuous medium of gas and dust, the raw material from which stars and planets are born. And in some regions of our galaxy, this material coalesces into vast, dense clouds, known as molecular clouds or interstellar dust clouds. What if Earth, in its long journey around the galactic center, were to drift into one of these immense cosmic fogs? These clouds are colossal structures, many light-years across, composed primarily of hydrogen and helium gas, but also containing significant amounts of microscopic dust grains, tiny particles of silicates, carbon, and ice. While diffuse by earthly standards, their sheer scale means that passing through one could have profound and long-lasting effects on our solar system, and specifically on Earth's climate and habitability. Imagine our solar system entering such a dense cloud. We now venture into a realm that is, admittedly, more theoretical, yet deeply unsettling because it touches upon the potential consequences of advanced, perhaps even malevolent, extraterrestrial technology. This is the concept of gray goo, a hypothetical doomsday scenario involving self-replicating nanobots unleashed from space, machines that could consume our entire planet from the inside out, transforming everything into more of themselves. The idea stems from the field of nanotechnology, the engineering of functional systems at the molecular scale. Imagine microscopic machines far smaller than a human cell, designed with a single, relentless purpose: to replicate. To do this, they would need raw materials and energy. And what better source of raw materials than an entire planet, rich in diverse elements? This is the core of the von Neumann probe concept. a space probe capable of self-replication using materials found on planets it visits. While some envision von Neumann probes as benign tools for exploration or even terraforming, the Grey Goose scenario posits a more terrifying application. Of all the cosmic threats we've explored, this next one is perhaps the weirdest, the most mind-bending, and, if it were to occur, the most utterly and completely unstoppable. It's a threat that comes not from an object or an explosion, but from the very fabric of reality itself, the possibility of vacuum decay, an event that could rewrite the fundamental laws of physics and erase our universe as we know it. This concept emerges from the cutting edge of theoretical physics, particularly quantum field theory and string theory. Some physicists hypothesize that the vacuum of space, what we perceive as empty nothingness, may not actually be in its most stable, lowest energy state. Instead, our universe might exist in what's called a false vacuum, a metastable state, like a ball resting in a small dip on the side of a much larger hill. It's stable for now, but not truly stable. If this hypothesis is correct, there exists a true vacuum state with a lower energy level. And like that ball on the hillside, it's possible for our universe, or a region of it, to tunnel through the energy barrier and collapse into this true vacuum state. Such a transition could be triggered spontaneously by a quantum fluctuation, or perhaps by an extremely high-energy event, like the collision of exotic particles, occurring anywhere in the cosmos, even in a galaxy billions of light-years away. Should such a phase transition occur, a bubble of this true vacuum would begin to form. Inside this bubble, the fundamental constants and laws of physics as we understand them would be different. For over a century now, humanity has been inadvertently, and sometimes purposefully, shouting its presence into the cosmic darkness. Our radio and television broadcasts, our radar signals, our dedicated messages sent towards distant stars, all of these electromagnetic waves have been propagating outwards from Earth at the speed of light, creating an ever-expanding bubble of human communication that now stretches dozens of light-years into space. We are, in essence, announcing our existence to anyone or anything that might be listening. The search for extraterrestrial intelligence, SETI, is predicated on the hopeful assumption that if we do make contact, it will be with a civilization that is curious, perhaps benevolent, or at least indifferent enough not to pose a threat. We dream of shared knowledge, of understanding our place in a galactic community. But this optimism is not universally shared, and the prospect of first contact carries with it a profound and potentially existential risk if our assumptions prove to be tragically naive. The late great physicist Stephen Hawking famously warned about the potential dangers of actively broadcasting our presence. He drew an analogy to when Christopher Columbus and other European explorers first arrived in the Americas. So, as we stand at the end of this cosmic tour of potential doomsdays, which of these formidable threats would you rather face, if choice were even an option? Would it be the sudden fiery annihilation from an asteroid, a sky literally burning above you? Or perhaps the silent, insidious grip of a solar superflare, plunging our technological world into darkness? Or would you opt for the utter cosmic mystery of something like vacuum decay, a threat so profound we can't even truly comprehend its mechanism, only its absolute finality? The universe, in its breathtaking grandeur and terrifying power, is undeniably vast. And while our Earth, our home, often feels like a sanctuary of stability and safety, this journey has shown us that this feeling is, in part, an illusion born of our limited perspective. It only takes one unforeseen twist of cosmic fate, one errant asteroid, one perfectly aimed gamma-ray burst, one encounter with the unknown to change everything, to unravel the delicate tapestry of life that has taken billions of years to weave. But this knowledge should not lead us to despair. Instead, it should ignite within us an even deeper curiosity, a more profound respect for the cosmos, and a stronger commitment to understanding our place within it. I invite you to subscribe to NexTen Space, where we will continue to explore these mind-bending cosmic truths every single week. Because the more we learn about the universe, its